Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all. Okay, morning lah because I'm recording this video morning, right? Okay, no problem with that. So today we are going to continue our chapter 5, Network in Graph Theory. For the learning standard for today, we are going to compare and contrast first directed graph and undirected graph. Secondly, weighted graph and unweighted graph. Okay. First of all, we look what is the difference between a directed graph and an undirected graph. Okay. A directed graph is a graph in which a direction is assigned to the edge connecting two vertices. If you look here, over here, there. Given this one is a direction, okay, between two vertices. Okay, if you look carefully here, for the edge AB, okay, A is the initial vertex. Meanwhile, for B, this one is our terminal vertex. Okay, so we start from A to B. Yes. Okay. For this edge, for the edge, if you look at HBC over here, if this one is undirected graph, okay, we are going to name the edge here is BC, right? But for this directed graph, we name it as CB because our arrow over here, direction over here is from C to B. So this one is our initial. Okay, initial vertex. Okay. Okay, if you look here, all the vertices are connected in one direction only. This one we call as a directed graph. Okay, so for example, for road maps, A-line networks, okay, you can read in your textbook, page 135. Okay, this is what the meaning of undirected graph. Okay, and undirected graph is a simple graph or graph with loops and multiple edges drawn without any direction being assigned. Okay, if this one normally we just name it here is for the edge here is 1 5 to 1 2, this one 1 4. Okay, normally like this. Okay, 2 4, because this one no undirected graph. Okay, undirected graph, so we just name it the edge like that because we don't have any arrow, okay, any direction for that. Okay, next, okay, we are going to look at the difference between directed graph and undirected graph. Okay, this one we're going to look at undirected graph for the simple graph first. Okay, what does, okay, we have here, okay, we have two differences we have. Okay, first is undirected graph, meanwhile here is directed graph. Okay, we look at the undirected graph first. Okay, if you look closely, okay, what did we have our vertices over here? Okay, the vertices we have over here is A, B, C, D. Okay, the number of our vertices is 4. Am I right? Okay, next, can you give me the edge for the undirected graph here? Can you list down all the sets over here? Okay, if you look closely, okay, normally we just name this edge AB and then AC. This one is CD. Meanwhile, this one is BC. Am I right? Okay, just name it like this. So we can put in our set of our edge over here is first of all AB. Okay, followed by AC, BC, and also CD. Okay, we have our set of our edge. So the number of the edge over here is 4. Am I right? Okay. So can I know the sum of the degree? Yeah, previously we learned about this one. Sum of our degree is 2 times with our number of edge. Am I right? So 2 times with 4, we have over here 8. Okay. So if you look here, the order of the vertices written is not important because this one we call as a undirected graph. Okay. Okay. If you look at for the degree A, okay, degree from vertex A, okay, how many degree did we have over there? Okay, we have 2. Am I right? Okay, we have 2 over here. 1, 2. So degree for A we have 2. How about vertex B? Okay, this one also 2. For C, we have 1, 2, 3. Okay, and or for vertex D, we have only 1. So the sum of the vertex, the degree here is also, yes, also give you 8. Okay, now going to look at our directed graph over here. Okay, for our directed graph over here, if you look closely, they are given the direction over there. Can you see that? Okay, first of all, okay, I want to list down my vertices. Okay, my vertices. What vertices did we have? Same like our undirected graph just now. We have A, B, C, and D. Okay, so the number of vertices also we have 4. Okay, same like our undirected graph just now. Okay, next I want to list down my set of my edge. Okay, if you look closely, just now, okay, wait, here. Just now we named this one AB, but for this edge we cannot same like undirected graph because this one given our direction already. So the order of the vertices are written according to direction of the edge. So instead we write down AB, we say this one as, yes, BA. BA, this one. Okay. How about this edge? Yes, this one not AC but CA because our initial vertex over here is C. If you look there, okay, our initial there is C, okay, and our terminal vertex is A. So we write down as CA. Okay, how about this H? Yes, this one is normal, BC. Why? Because our initial is B, our terminal is C. This one, yeah, DC. So all are written according to the direction of the edge. So when we want to write down all the sets for our edge here, okay, we can start with BA followed by BC, then CA, and lastly we have DC. Okay, so what is the number of our edge over here? We have 4. Okay, now I want to list down my degrees. Okay, for your information, for our initial over here, initial is say, okay, for in and out, for in and out. Okay, if you look at our vertex A, okay, if you look closely at vertex A, if you look at the direction here, this is means in, okay, means the degree in. Okay, we name it as D in. Okay, D in for A. Okay, D in for A means that, okay, if you look at the direction for vertex A, there are 2. Okay, just now. Okay. Okay, next we have our out. Okay, out from the D out. Okay, if you look at D out, what does mean D out from A? Means from A, is there any direction out from the vertex A? None. So we just write down 0. Okay. Next, for vertex B. Okay, for vertex B, if you look at vertex B, okay, the direction involved only for this one and this one. Okay, is it in or out? If you look there, yeah, this one all are out. Is there any in to vertex B? None, right? So we just write down D in for vertex B 0, D out for vertex B is 2. Okay, class? Okay, next. We look at vertex C. Okay, for vertex C, is there any in? Yeah. How many in? Correct. There are 2 here. 1, 2. Okay, the green one. So I just write down here for degree in for vertex C, I write down 2. Okay. How about out from our vertex C? Yeah, only 1. So we just write down here D out, degree out from vertex, not vertex B, vertex C is 1. Okay. Last one. If you look here for vertex C, there are only one direction given over here. It's out. Am I right? Is there any in for the vertex D? None. So we just write down here D in for D is 0. D out, degree out from vertex D is 1. Okay. So now I want to sum up. Okay. For the directed graph over here, I want to sum up the degree. So, if I want to sum up the degree over here, I just count all together. Okay. 2 plus 0 is 2. 0 plus 2 is 2. Okay, so over here we have 2. We have 2. This one we have 3. 2 plus 1, 3. This one, 1. So, all together we have is, yes, 8. Okay. Same like, just now. Our undirected graph. Okay, the difference, this one is our direction given. Okay, and also how we write down our age. Okay, if you look here, it's different. Okay, but the same here is what? Yes, this one is same. Our sum of the degree is the same. Cannot be different, because this one is same graph, but one is undirected graph, one is directed graph. Okay, so next we are going to look, okay, graph with loops and multiple edges. Okay, also the same one. Okay, also same graph, but okay, both have the first one have undirected graph. Okay, no direction, right? So there are direction given there for the directed graph. Okay, what is the difference? Okay, now I'm going to discuss this one. Okay, first of all, for this undirected graph, first of all, I want to list my vertices. Okay, what vertices do I have here? Okay, P, Q, R, S, T. Correct. Okay, next, I'm going to look at my edges. Edges given there. Okay, we just know that this one is our PT. Okay, this one is PT. This one is PQ. Okay, PT, PQ. Okay, next we look here. We have our, this is our multiple. Okay, multiple edges. This one is multiple edges. So we have over here, the one here is QR. This one also QR. Okay. Okay, next, Q also we have with QS over here. Okay, QS, the H over here. Next we have ST. Okay, we have our loops over here. We call it as a TT. Okay, so for the sets of our edges over here, we can list as PQ, PT, okay, and then followed by QR, okay, and then we have QS, and then ST, and then TT. Okay, we have how many of it? Okay, 1, 2, 3, 4, 5, 6, 7. Okay, we have 7. Okay, number of our edge is 7. Okay, so to find our sum of our degree over here is 2 times with number of our edge, so we have 14. Okay, class? Okay, now if you look closely over here, okay, so if you look closely over here, from the vertex P, okay, from the vertex P over here, okay, how many are the degree given there? Yes, there are 2. For Q, how many? For Q is 4, am I right? 1, 2, 3, 4. So, sorry, this one for P. This one Q is 4. Okay, for PQ, for R. Okay, for R, how many degree for R? There are only 2. For S, also 2. Okay, also 2. And for T, okay, T is how many? Yeah, there are 4. 1, 2, 3, 4. 4 also. Okay, so we have our degree for T is 4. Okay, so the sum of the degree over here for this one, 2 plus 4 plus 2 plus 2 plus 4, so we have 14. Okay, now we look at our directed graph. Okay, for the directed graph, remember we look at the direction given, okay, and then for the edges, we're going to write according to the direction of the edge. Okay, so now going to list down my vertices first. So P, Q, R, S, T, same, right? Okay, next my edge. Okay, so this one, look carefully. The first one we have over here is PQ according to our direction at the edges given there. So we have PQ. Next, what we have over here, okay, PT. So can you name it as PT? Cannot. Why? If you look at the direction there, okay, this one, the initial is T, am I right? And the terminal is P. So we just write down here is TP. Taman Petaling, my school. Okay. Next, okay. Next is at the P vertex P done ready. Okay, we look at Q. Next, we look at Q there. Okay, we have, if you look closely over here, give you a big one. Okay, Q. Okay, the direction here is, yes, we just write down here Q R, but this one, if you look at the direction here, the initial is R, so we start with R and followed by our terminal is Q, so RQ. That's how you write. Okay, next, at the edge below here, we have, yeah, correct, SQ. This one, yeah, TS. Okay, for the loops, if you look for the loops, okay, for the loops over here, is there any direction? No, loops is no direction. So we just know that this one only TT. Okay, class? Okay, so if we're going to list down over here, we have the first one, we have PQ. Okay, class. PQ. Next, QR. Okay. And then RQ. Okay. Followed by SQ. And then TS. Okay. Okay. Next is TT. And lastly is TP. Okay. TP. Okay. So number of edge over here we have also, yeah, same. 1, 2, 3, 4, 5, 6, 7. Okay. So for this one also, if you look closely, I want to find my sum of degree is 2 times with 7, I have my 14 over here. Okay. So if I want to list down, okay, I want to list down my degree for every vertex over there. Okay. For P, it's the same. Okay. For P, okay, for degree in for P. Okay, so I want to look at the degree in for P over here. P, is there any in? Yeah, 1 only, right? Okay, so we write down 1. Then D out from vertex P. Okay, from vertex P. How many out there? Yes, only 1. Next, D in for vertex Q. Look closely. In from vertex Q. How many can Q given there? Yeah, 1, 2, 3. All in for Q over there. So I have 3. Is there any out from the degree out from the what? From the vertex Q? Yes, only 1. So D out for vertex Q is 1. Okay, next for our vertex R. Is there any in? Yeah, only 1. Is there any degree out from vertex R? Yes, only 1. Okay, next we look at vertex S. How many in for vertex S? If you look here, only 1, right? This one. So this one we call is in for vertex S, only 1. Out also over here is 1. Okay, last vertex we have over here. Okay, this one, be careful because we have our loops there. What does mean by loop here? Means that for in 1, for out also 1. Okay. So for loops over here, we have for in for T, because this one loops. Okay, 1. Okay. If you look closely for degree out from T, okay, this one is considered as out also. Am I right? And this one, if you look, this one also out. Okay, from T. Okay, and then this one also, because there are loops, so we consider it as out also. So the degree out coming out from vertex T, we have 3. Okay, be careful with loops. I repeat again, with loops, for in 1, for out also consider as 1 for loops. Okay, so the total over here, if you look closely, okay, for P we have 1 plus 1, we have 2. This one, 3 plus 1, we have 4. 1 plus 1, we have 2. 1 plus 1, we have 2. And 3 plus 1, we have 4. So if we sum all together, all the degree for the directed graph over here is 2 plus 4 plus 2 plus 2 plus 4. So you have also 14. Okay, this one for our undirected and directed graph, for graph with loops and multiple edges. Now we are going to discuss our example 7. Okay, For example 7, if you look here, okay, there are A and B. Okay, so I just put it differently. Okay, we're going to find the answer for A first. Okay, draw a directed graph based on the given information. Okay, now we are going to draw. Okay, previously we also draw the graph, but simple graph, but this one is different because we have directed, we have a direction. Okay, so first of all, what you must know, how many vertices involved? There are 2, 4, 6. Okay, 6 vertices involved, am I right? So you can draw over here, okay, 1 P followed by, okay, this one look carefully. Okay, look carefully because we want to determine first. Okay, sorry. We are going to determine first because our edge over here. Okay, for P, they are going, initial is P, Q, P, R. Means that P going to Q, going to R. Am I right? Okay, P, Q, P, R. Okay, R, Q means that R going to Q over here. Okay, S, R. Okay, we have S connected to R. And then S connected to Q. That's what I mean. Because we are going to draw, right? Okay, and then S connected to T. Okay, so you can draw, you cannot simply draw. Because, okay, if you just draw like this lah, okay, I give you example P, Q, R, S, T. P, Q, R, S, T, U. Okay, U. If you look over here, there are no U here, right? So means that U here is isolated. Is an isolated vertex, okay? So, okay. If you want to draw, okay, look closely, PQ, okay, PQ, we have here. Remember, we must draw the arrow of the direction, and then PR, how you want to draw? That's why I said, okay, so means that for this example, we cannot draw like this our vertices. Okay, so let me draw again. Means that P is here, and then we know that Q and R connected with our P, right? Okay, so I just put here our Q, and then over here is our R. Why? That one is connected here. If you look closely here over here, P is connected with Q and R. S is connected with R. So I put here is S. And then T connected to S. So I just put here T. And I also put here U. Okay. So when I want to draw, okay, P connected to Q first. Okay. Okay, so the edges given over here, PQ. Am I right? Then PR. Then PR. So we just draw our arrow P to R. And then RQ. Okay, we have over here RQ. Okay, and then don't forget our arrow of the direction SR. Okay, SR. From S going to R. Okay, SR, and then followed by SQ. Okay, SQ, and then we have ST. Okay. Okay, ST. Okay. So, U, is there any edges between any vertex with U? No. So this one, we just assume this one as our isolated vertex. Okay. So you can draw like that. Okay, it's up to you. Okay, so remember, you must determine first the pair of the vertex and the direction. Okay, next. Still as example 7. Okay, draw a directed graph based on the given information. Okay, there is a loop. There is a loop at vertex Q, and R is a multiple H. Okay, first of all, I want to look at the vertex given first. Okay, so the vertices given here P, Q, R, S. Okay, and then the given also the degree in and the degree out there. Okay, so first of all, I want to draw my vertices for P, Q, R, and S. Okay, next. There is a loop. Okay, what does it mean loop? Okay, this is our loops. Look like, oh, sorry. Loops. And then, given also, RS is a multiple H. So we have our RS over here. R to S. R to S over here. Okay, the multiple H. Okay, now we are going to look at the degree given there. Okay, degree in for P. Okay, so it's connected over here. P out, Q, Q. Okay, so we have over here. Okay, so we have over here. I want to draw the connected, the H first. Okay, P in 1, out 1. So means that 1 is in, 1 is out. Okay, so I put here. Okay. Okay. Next, how I want to determine first. Okay, this one, degree in Q is 3, out is 2. So the loops here counted as 1 for in. Okay, out also 1. So in over here we have 3. Means that this one is out from P. This one out for Q. Because why? Because, okay, this one, okay, the loops over here is considered as 1 for in, out also 1. Am I right? So if you look here, this one loops given 1 for the degree in for Q, and then how 1 only, but this one stated as 3. So this one is 2. So this one is 3. Just put like that. So the degree in for P over here is 1. This one out already, 1. Okay, so we know that this one, the arrow of the direction is like that. Okay, class? Okay, out from Q is 2. Okay, out from Q is 2. Okay, 1 is considered in our loops over here. Where is one more? Okay, this one connected between the H between P and R cannot, because this one involved in already for our vertex Q, right? So we have one more vertex, which is our vertex, yes, vertex S. Yeah, connected from, so this one is out from Q. So we just put arrow of the direction of like that. Okay, next, in for R is 0. Okay, in, the degree in for R is 0. Means that all are out only. So just put like this and like this. Okay, out, okay, in 0, out is 3. Okay, this one is considered out 1, out 2, out 3 from the vertex R. Okay, class? Okay, next, the degree in for S is 3. Okay, in 1, 2, 3, correct. Degree out from S is 1 over here. Out. Out from S, vertex S to vertex P. Okay, class? That's how we draw. You're going to look at the degree in and degree out from our vertices given there. Okay, next. We are going to look at the next. This one. Okay. What are the differences between weighted graph and unweighted graph. Okay, what is weighted graph? Okay, directed graph and undirected graph. Okay, same. This one type of the graph is same for weighted and unweighted. Okay, we can give a directed or undirected graph, but the difference here is our h. Okay, this one associated with a value or a weight. Okay, given there a value. But for unweighted graph, not associated, not given any value or weight. Okay, for example, for weighted graph is distance between two cities, traveling time, the current in electric circuit, or cost. Okay, for unweighted graph is job hierarchy, flow map, tree map, bubble maps, and so on. Okay, so we look at example for the weighted graph like this. Example 8. This is weighted graph. Given the value there. Given the value over there. Okay, this one is directed weighted graph. Oh, no, directed. Yeah, because given there the arrow, right? Okay. Now, the diagram on the right shows one-way path that Izarul can choose for his running practice. Okay. During PKP, no. Cannot, cannot run. Cannot jogging also. Okay, vertex V1. Okay, where is our V1? Okay, there is the starting position. Okay, given over here already, our start position over here. And vertex V5. Okay, over here is our ending position before he goes home. Okay, determine. Okay, don't look at the question yet. Okay, first of all, from the weighted graph given here, we going to came out what is given first. Okay, first of all, okay, V1 start with V1. Okay, V1. We're going to look. Okay, we are going to do this direction first. Okay, V1. We are going to go to V2. Also V1 we can go to V3. Okay, so V1 we can go to V2. V1 also we can go to V3. Okay, there are two options there. Okay, next. V1 to V2, because we start right. V1 to V2. Okay, and then V2, there are two direction also. Go to V4. Okay, and then go to V5. Okay, so V1 over here. Okay, we have two. V2, V1 to V2. V2 also we have to V4. One more to V5 straight away. Okay, V1 to V2. Okay, V2 to V4. Okay, V2 to V5. Okay, V4 here, if you look closely, only going to V5 over here. Okay, the next one, V1 to V3. Okay, V1 to V3. We have V1 to V3 over here. V3 straight to V4. Cannot go anywhere else. Okay, straight to go V4. And then V3, V4, V5. Okay, all together. Okay, we look for this one. Okay, for this one, V1 to V2 to V5. This one, the first one. Okay, next. Okay, we have our, 5 over here. Okay, next we have the second root. Okay, given here, V1, V2. Okay, V1, V2, V4, and then V5. The second root over here. Okay. Then, the third root, we have V1, V3, V4, and then V5. Okay. All roots given. Okay. Now, if you look closely, class, we have another root given there. Another root given. What? V1 to V2, V2 to V3. if I do there, no, none, right? Here. This one. V1 to V2, V2 to V3, V3 to V4, V4 to V5. This one is V1 to V2 to V4, V3 to V4 to V5. This one the longest one, I think. Because the question, if you read the question, you know that, right? Okay, so now we are going to look at the weighted or the value given there. Okay, first of all, V1, V2, V5. V1 to V2 is 600. Okay, 600 meter plus V2 to V5, 500. Okay, V1 to V2, 600. Okay, plus V2 to V4, 800. Plus V4 to V5 is 500. Next, V1 to V3 is 500 plus V3 to V4 is 500 plus V4 to V5 is 500. Okay, this one. V1 to V2, 600 plus V2 to V3 is 900 plus V4, okay, V3 to V4 is 500 plus V4 to V5 is 500. And this one is the longest one. Okay, so if we sum all together over here, so we have here 1100. Okay, this one we have 6 plus 8 is 1419. This one is 15. This one we have 6 9 5 5000 250. Okay, all are in meter. Okay, now then I'm going to look at the question. Determine, okay, sorry, the ruler is disturbed. Okay, determine the shortest distance from V1 to V5. If you look closely, which one is shortest distance? Yes, this is the shortest distance. Our answer for A. We answer already. This one A. Okay, V1, V2, V5. We get 1100 meter. The longest distance, of course, if you look closely, this one is longest distance, B. Am I right? Okay, 2500 meter. Okay, and then determine the the vertices that must be passed through if the distance of the one-way run is between 1.4 kilometer and 2.1 kilometer. Okay, so we are going to convert all this into kilometers. So we have 1.1 kilometer, 1.9, 1.5, and 2.5 kilometer. So between, given here, 1.4 and 2.1. 1.4, this one not included. 2.5 also not included. So the answer, which one? Yes, V1, V2, V4, V5, V1, V3, V4, V5. Because the answer, the vertices. Okay, determine the vertices. So this is the answer for C. You have to answer all this. This one. Okay. So I hope you can understand for today. Okay, I repeat back. Okay, I give a conclusion. We know already about our directed and undirected graph. Okay, you know what is the difference between directed and undirected graph? Yes. Okay, the H given here, we have a direction. Okay, between directed and undirected graph. Okay, and remember for the loops, if loops given in, one, out, also one. Okay, Okay, so for the second learning outcomes, we know about our weighted graph and unweighted graph. Okay, what is difference? Okay, a weighted graph we have value or weight, okay, given, and unweighted graph they are not given, not associated anything. Okay, so I hope you can understand for today learning. So give a benefit for you this video. Please don't forget to subscribe to my channel, and also please like the video, and you can share with your friends. Okay, until we meet again. Okay, assalamualaikum warahmatullahi wabarakatuh, and bye.